All right, guys, chapter 1, section 2b, we're solving rational equations. You guys remember what rationals are? Just grown up what? Grown up fractions. So we're going to have to get a common denominator, and then we're going to solve. All right, a couple of different ways you guys can do this. Again, personal preference. I'm going to work through them, and then if you see it a different way but get the same answer, totally fine. But you need to eliminate your fractions by multiplying by the least common denominator. And you have to check your answers for extraneous roots. What does that mean, extraneous roots or extraneous solutions? Anybody know? There's solutions that when you plug them back in, they make your equation untrue. So we're going to have to be careful with stuff like that. So if you look at something like number 1. All right, number 1, if you were going to get a common denominator, and remember, this is over 1, correct? What would your common denominator be between 3, 4, and 1? 12, okay? 12. So you can figure out what you need to do to each equation, to each fraction, to make it have 12 as the denominator. Or you can just look at it and say, I'm going to multiply the whole equation by 12. Either way you want to look at it, you are perfectly fine. You can do it each separately, or you can do it all together at one time. All right? So if I say 12 times x divided by 3. What does that give me? What's 12 divided by 3? So I have 4x. Then I say 12 times 3 divided by 4. What's that going to give me? What's 12 divided by 4? 3. Then 3 times 3 is, so 9x. And then I'm going to multiply 12 by 2, and I get how much? What's 12 times 2? 24, okay? Another way you guys could look at it, if you want to get all the common denominator. You said, how did I make a 3 into a 12? You multiply by 4, right? What you do to the bottom, you do to the top, so this becomes 4x. How did I get 4 to become 12? I multiplied by 3, so what you do to the bottom, you do to the top, this becomes 9x. And then how do I make this denominator 12? Well, I multiply by 12, what you do to the bottom, you do to the top, so I get 24. And then once you have a common denominator, you can eliminate it. That's exactly what we did, just when I multiply the whole thing by 12. So either way you see it, whatever, it's up to you guys. But what is 4x plus 9x? 13x, okay, so I get 13x equals 24, and then what? How do I get x by itself? Divide it by 13, so you get x equals 24 over 13. Is that the easiest thing in the world to plug back in and check? No. It does work. I worked all these out and made sure that they all work, but this does work. But guys, on a test or a quiz, you need to plug back in. You need to check. Some of you are going to make silly mistakes, and then you can find your silly mistakes in doing this. When we talk about extraneous solutions, you'll see in a second. Asir, did you have a question? Okay. All right, let's look at number 2. I always go to the right. All right, this is over 1, correct? So what's our common denominator going to be between 5, 1, and 13? 15. Okay, so I'm going to multiply the entire equation, everything, by 15. Do you guys like me doing that, or would you rather do the common denominator part? No one's going to talk to me today? Okay, great. All right, let me do it this way. Our common denominator is going to be 15, yeah? So let's look at this. How would I make 5 into a 15? I'd multiply by what? 3. So what you do to the bottom, you do to the top. So that gives me 6x. How do I make 1 into 15? Multiply by 15. What you do to the bottom, you do to the top. So what's 5 times 15? 75, okay. Excuse me. How do I make 3 into 15? Multiply by 5. What you do to the bottom, you do to the top. And so we get what? 4 times 5 is 20. All right. Now that you have all the same denominator, you don't have to worry about it anymore. It's gone. Left-hand side, same as right-hand side. So now we solve. What's 6x plus 75x? 81x equals 20. Divide both sides by 81. What's x equal? 20 over 81. Can you simplify that at all? No. If you can simplify, simplify. If you have an improper fraction, you can leave it as an improper fraction. Just make sure it simplifies. Again, is that the greatest thing in the world to plug back in and check? No, but I suggest that you do it. Let's look at 3. We'll go back and check some of these if you want me to. I just want to get through all of our examples, and then I'll go back and look. All right, so I now have 4 different fractions that I'm looking at. What is the common denominator going to be between 5, 2, 1, and 10? 10, okay. So let's see what we need to do to each. What do I multiply 5 by to make it a 10? 2, so what you do to the bottom, you do to the top, correct? So you have 2x. What would I do with my 2 to turn it into a 10? Multiply by 5, so what you do to the bottom, you do to the top. So this is minus 5x equals, well, what would I have to do with 1? What would I multiply 1 by to make it 10? 10, what you do to the bottom, you do to the top. So this becomes 30. Then do I need to do anything with 3x over 10? Nope, just stays as 3x. So now we combine like terms. What's 2x minus 5x? Negative 3x equals 30 plus 3x. At this point, guys, don't go, oh, the x's cancel out. This is no solution. Is that the case? No. Don't try to skip steps. Move your x's to one side. If I move 3x over here, this becomes negative 6x equals what? 30. Divide both sides by negative 6. And what does x equal? Negative 5. Is this one a little easier to check? Yes. You guys are more likely to do it. I understand that. But you have to make sure that you check your answers. Anybody have any questions? Everybody's okay. All right, let's keep down to number 4 then. All right, now we don't just have just numbers. What would a common denominator be here between x and 1? What would it be? 1x, right? Okay, so x. In my mind, I'm trying to make everything equivalent so I can get rid of my denominator. 15 has an x as a denominator. I'm leaving it alone. Minus. How would I change 1 into an x? I multiply by x, right? What you do to the bottom, you do to the top. So this becomes minus 4x equals. Do I need to do anything to 6 over x? Guys? No, so this stays. And then what do I have to do here with 3? I multiply x on the bottom of the top. So here and here, so this becomes 3x. All right, now that we have made each side of the equal sign have a common denominator, you don't have to worry about it anymore. It's gone. You've made it equivalent. So now we just solve. I'm going to subtract 3x from both sides. And I'm going to subtract 15. So 15 cancels over here. I have negative 7x. Equals, what's 6 minus 15? What is it? What is it? Okay, I thought you said 8. And then what happens with my 3x's, my negative 3x? Cancels. So x equals what? Not positive 9 over 7. Negative divided by a negative is a positive. So positive 9 over 7. Questions. Not the most beautiful things in the whole world, but nothing you guys can't handle. Abigail, you good? Yeah? Okay. Just make sure. All right, what do you guys notice about 5? It's a binomial. Good. What else do you notice? What I tell you could do when you have a fraction equal to a fraction? You just cross multiply. All right, you have one fraction on the left-hand side, one on the right-hand side. So let's cross multiply. I have 1 times 5x plus 6 equals 2 times 10x plus 3. If you wrote 2 times 10x plus 3 on the left-hand side and 5x plus 6 on the right, that would have been fine. So 5x plus 6 equals, when we distribute, what does this become? Good, 20x plus 6. Now let's move letters to one side, numbers to the other. I'm going to subtract 20x from both sides and subtract 6. So I have negative 15x equals what? Equals 0. Is this no solution? No. If it said negative 15 equals 0, correct, no solution. But this, you can solve this. I can divide both sides by negative 15. What is x going to give me? If I divide 0 by negative 15, what does that give me? 0. Perfect. Can you plug 0 back in here? Yeah. Say it one more time.
I kind of got like 4x, so like together, does that make sense? The 4 and the x.
The 4 and the x. All right. We were going to combine here. We're going to solve. We're going to answer this question. I want to know, what does x equal? So I need to have a common what? Okay, so let's think, what would our common denominator be between x and x minus 5? X times x minus 5, right? I'm just doing some side work over here to the right, so you guys are seeing what your fraction is starting off with and what you want it to end up with as a denominator. So 1 over x has the x, what's it missing? The x minus 5, okay. Plus 2 has the x minus 5, what is it missing? Gx, good. And then I have 0, and I'm going to times it by x and x minus 5. Everybody agree? Okay. So we distribute. I have x minus 5 equals, no, I don't. I have x minus 5 plus 2x equals what? Equals 0, good. What can I combine on the left? 2x and the x gives us, so 3x minus 5 equals 0. Now what? Okay, plus 5. So 3x equals 5. And then what? Divide by 3, and x equals 5/3. All right, here's where we're really going to get to where it's important to check for extraneous solutions. Where do you have an issue here? What could not be an answer for this question? There's two things that you could absolutely, if you came out that x equals this, you'd have to say, not true. What are the two numbers? Frank, tell me.
5.
Yep. Why is 5 not okay?
Because if x equals 5 and 5 minus 5 is good.
Yeah, what happens here in my denominator if I have 5 minus 5? It becomes undefined, right? What's another issue that we would have?
If x equals 0.
If x was 0. Because you can't plug something in and have a true mathematical statement where you get an actual solution if your fraction is undefined. So in this case, guys, if you took 5/3, is there any way you could plug 5/3 in for x and get an undefined fraction? No. So you're fine here. But that's where you really need to be careful with these rational functions, is if the denominator, the answer that you got, would make the denominator become 0. That's where the major issue lies. Keep forgetting there's other stuff over here. All right. This problem gets a little lengthy, but it's nothing you guys can't handle. What is my common denominator going to be between 2x plus 1, 2x minus 1, and 1? Yep, 2x plus 1 and 2x minus 1. So my first fraction, the 7, it has the 2x plus 1. What is it missing? The denominator was going to be the same. If it has the 2x plus 1, what's it missing? The 2x minus 1, okay. I have a minus sign there, guys, be careful. So I have 8x here. I have the 2x minus 1 in this fraction. What is it missing? 2x plus 1, good. And on the other side of an equal sign, I have a negative 4, and what is it missing? 2x plus 1 and 2x minus 1, good. All right, now we got a lot of algebra here to deal with. I'm going to distribute. 7 times 2 is 14x. 7 times negative 1 is? What kind of 7? Negative 7. Careful with signs. Then I have negative 8x times 2x is negative 16 what? X squared. I have a negative 8x and a positive 1. It's going to give me negative 8x. Yeah? All right, then on this side I have negative 4. If I'm going to FOIL out 2x plus 1, 2x minus 1, what does that give me? Four x squared minus 1. Good. Some of you guys got to like 4x squared minus 1, and they didn't factor more on your test. That's where you lost some points, stuff like that. All right, we could do a little more simplification. On the left-hand side, how should I rewrite the left-hand side? How should I rewrite the left-hand side? Hold on. Hold on. What?
Why wouldn't you multiply the 2x plus 1 and 2x minus 1 by -4?
I'm going to.
Huh?
I'm going to.
Oh.
I'm just simplifying from the left to right. You can go ahead and do it now. But on the left-hand side, I have negative 16x squared. Then what? 14x minus 8x is going to give me minus 6x. Agreed? Yes, guys? Okay. And then what? Minus 7. Okay. Some of you are like, oh my gosh, I already got to factor this. Just relax for a second. Now we're going to distribute, like Angel just said. What's negative 4 times 4x? It's going to give me negative 16x squared. Yeah. Negative 4 and negative 1 is what? Plus 4. All right, I do have a quadratic. How do I know it's a quadratic? Well, because I have x squared. That makes it a quadratic. So let's just move everything to one side. Let's see what happens here. So if I add 16x squared here, and I add 16x squared here, what happens? What's a positive and a negative 16x squared? They cancel. So now you don't have to worry about, oh no, do I need to factor anything like that? Your x squared is canceled out. So now it's just x on one side, numbers on the other. Yes? So what can I do here? I'm going to add 7 to both sides. Okay. You guys agree? So negative 6x equals 11. And now what? Divide by negative 6. So x equals negative 11/6. Beautiful number, isn't it? Where do I need to check just to make sure what does not happen? If I put in negative 11/6, if I put it in right here, 2 times negative 11/6 plus 1, is that somehow going to give me 0? No. If I put in 2 times negative 11/6 minus 1, is that somehow going to give me 0? No. So you guys are okay. We're good. Questions on that? That's a yucky problem. Here's another one. What should we do first before we even start trying to get a common denominator?
X squared.
Yep. What should I do with x squared minus 4? Perfect. Difference of perfect squares. Good. That might make things a little easier for you guys to look at. What's a common denominator going to be between x minus 2, x plus 2, and x minus 2, x plus 2? X minus 2, x plus 2, x plus 2, x minus, doesn't matter which order you do it in. So I'm going to look at each fraction independently. My first fraction, 1 over x minus 2. It has the x minus 2. What is it missing? X plus 2. Good. Notice this is written backwards, so now you have your equal sign. My second fraction has the x plus 2. What's it missing? If it has the x plus 2, what's it missing? The x minus 2, okay. So 3 times x minus 2 minus 6x. Do I have to multiply 6x by anything? No. Okay. So I have x plus 2 on the left-hand side. On the right-hand side, I have what? 3x minus 6 minus 6x, okay. Can I combine like terms on the right-hand side? Yep, okay, so x plus 2 equals negative 3x minus 6. Great, now what? Move letters to one side, numbers to the other. What do you want to do? I'm going to add 3x and subtract 2. So you're left with 4x equals negative 8. Agreed? Okay, divide by 4, and x equals what? Negative 2. Now, some of you are going to circle this and go on to the next one. Pat yourself on the back because you got a pretty number. But what do we need to check? Let's plug it back in. I don't have to redo the whole thing, but if I stick negative 2 here, what's negative 2 minus 2? Is that 0? No, so we're okay here. What about if I put negative 2 here? What's negative 2 plus 2? 0. That's a problem, guys. So actually, x equals negative 2 is an extraneous solution. Your answer here is no solution. If you were to work through this problem, get x equals negative 2, and then move on to the next, that's a major issue. That is not the solution to this equation. because what happens when you plug that number back in? It makes your fraction undefined. Do you guys understand that? That's what's so important about checking. Just because you get a gross looking number, it doesn't mean you did something wrong. But just because, oh shoot, pretty number doesn't mean you did something right. So just pay attention to that. All right, look at number 9. We're almost done then. Isabel, I'll go over yours. What's a common denominator going to be between x minus 4 and 1? X minus 4. Okay, so your first fraction has the x minus 4. My second fraction does not. So what do I need to multiply 1 by? X minus 4. So what you do to the bottom, you do to the top. And then do I need to do anything with my third fraction? No, it already has what we're looking for, right? Our common denominator was x minus 4. So I need to figure out what fraction has, what fraction needs, and then we do our math. Then we math it up. So 3x equals 5x minus 20 plus 12. You guys with? Okay. So 3x equals 5x minus what? 8. Good. Let's subtract 5x from both sides. So negative 2x equals negative 8. Now what? Divide by negative 2. What's x equal? 4. Okay, we came out with x equals 4. Great. Is that our solution? Why not? Look, if you plug 4 in right here, guys, what happens? 4 minus 4 is 0. That's no bueno. So your answer here is actually no solution. Yeah? We okay? Everybody all right? All right, number 10 looks a little daunting, but it's really not. They've already figured out the common denominator for us, correct? So let's just figure out what each piece has and what it's missing. 12 needs nothing. We have the x minus 1 and the x plus 3. So equals, I have 3. My fraction of 3 has the x minus 1. What is it missing? X plus 3, good. Then I have plus 2. I have the x plus 3. What is it missing? X minus 1, good. And now we just math. So 3x plus 9 plus 2x minus 2. Everybody agree? All right, so 12 equals, 3 and 2 is going to give me 5x. 9 minus 2 is going to give me plus 7. So I'm going to subtract 7 from both sides. Ooh, is this what I usually like to do? No. That actually makes my skin go like a little bit. I know I'm a weirdo. So now I divide both sides by 5, and I get x equals 1. Well, let's check. If I plug in 1 right here, what's 1 minus 1? 0. That's no bueno. If I put 1 in here, 1 minus 1, 0. Is 1 a solution, guys? No. So your answer here is no solution. Should we just assume that the rest of them are going to be no solution because I'm trying to really drive a point home? Sure, go ahead and do that. See what happens. Let's look at the next one. What should we do first and foremost, ladies and gents? Let's factor, all right? What are the factors of negative 6 that are going to multiply to give me negative 6 that add to give me 1? X minus 2, x plus 3, I agree. All right, so now looking at our lovely problem, do we already have the common denominator? Yes. It's just x minus 2 and x plus 3 stuck together. So my first fraction has the x minus 2. What is it missing? The x plus 3. My second fraction has the x plus 3. What is it missing? The x minus 2. And 4 has everything it needs. So now distribute x plus 3 plus 3x minus 6 equals 4. Combine like terms. X and 3x is 4x. It's a positive 3 and a negative 6. Minus 3 equals 4. Add 3 to both sides. 4x equals 7. So x equals what? 7/4. What should we check? What's our main goal right here? Yes, you should check. Plug it back in, make sure it makes the equation true. But what are we really looking for? To see if the denominator becomes what? 0. So if I take 7/4, and I say 7/4 minus 2, is that going to give me 0? No. If I say 7/4 plus 3, is that going to give me 0? No. So then I know if I multiply those two together, I'm not going to get 0. So 7/4 is a solution. Make sense? All right, last one. All right, number 12. Let's go through our process of how do we figure out the left-hand side, the right-hand side, our common denominators. What should I do first? Factor. What can I take out of x squared and 3x? I can take out an x, then I'm left with x plus 3, correct? There, we've discovered our common denominator. So I look at my first fraction. I have an x in my denominator. What is it missing? The x plus 3. So I say 6 times x plus 3. Minus that 2. Remember, that minus is there. So that second fraction has the x plus 3. What does it need? Just the x. Good. And then we're good to go over here. If you wanted to distribute already, you could. Just writing it all out. So now we distribute 6x plus 18 minus 2x equals 3x plus 15. You guys with? 6x minus 2x is 6x minus 2x. Okay, plus 18 equals 3x plus 15. X is to the left, numbers to the right. So minus 3x from both sides, minus 18. So x equals negative 3. All right, if I stick negative 3 in here, are we okay? That's not going to be 0. We're good. What happens if I stick negative 3 in here? It becomes 0. So is this actually a solution? So your answer here is no solution. Good. Now, when you guys go to do your web assign, it'll say in the instructions, I'm not sure exactly, I'd have to look at it again, but you might have to answer if you get no solution as no solution. It might be does not exist. Just read the directions before you guys come to me like, I don't know what to do. I'll probably be like, read. And then you're going to go, oh. So just do that before you do them. But practice these, guys. Start now. So if you have questions, we can go over it. We can talk for a minute. We okay? Okay.